Hello and welcome back to part 3 of this video series. In this video, we will create a similar application as video 2, but the only difference would be that this app will receive or read messages from the SQS. If you remember, towards the end of video 2, we were able to publish some messages on our AWS YouTube demo SQS. These messages are still available, and during this video, we will prepare an app which will read these messages from this queue. So we have all these messages available right now on the queue, and once we have our application ready, we will be able to read these messages off this queue. So we are back to our Eclipse, and as you remember, we had this AWS SQS publisher application using which we were able to put those messages on the queue. We will create a very similar application, but this time the role of that application would be to read the messages of the queue. So let's get started and create that SpringBoot application. SpringBoot startup project, and we are going to name this as subscriber. Nothing changes here, the same package, this Gradle Java 8 jar group remains the same, the package remains the same, and almost all those dependencies which we used for the publisher project, we will use the same dependencies for this project too. And click finish. Now that we have our subscriber project ready, I'm going to copy over some of the files and properties from the publisher project, as those things remain unchanged. So let's start with the application YAML. These properties will remain the same apart from the port number, because at some point of time we may want to run both the applications simultaneously. So I'm going to quickly change this from properties to YAML. I like YAML better. And I'm going to copy these properties as is from the publisher application to the subscriber application, and I'm going to run this application on 8060, and everything else remains the same because it's the same queue from which we want to read the messages from, and the rest of the properties also remains the same because we're going to run this subscriber application also locally, so there is no need for us to auto configure the cloud configuration for SpringBoot. The next thing we want to copy over is the client, because the client also remains the same, just that the implementation of this service will change. So let's do that. We are here. I'm going to create a package first, and this will be .client, and I'm going to copy this class over to this package over here. Yep. So we copied over the client. Since the properties are same, we want to have this class as singleton. The SQS remains the same, the client remains the same, and the credential mechanisms also remain the same because I'm using the same local system, and the same mechanism for creating and initializing this basic SQS client. So far there is no difference between the publisher and the subscriber, because the way we connect to AWS SQS remains the same. It's just that the functional aspect of the things will change. The publisher was trying to send a message using the publisher service, versus now we will create a new service within our subscriber application, and that will try to read the messages of the queue. For our next step, we will start creating AWS demo message subscriber service, the way we created the publisher service in the publisher project. So I'm going to quickly create a new package, and this is service package, and this will create a new class, AWS demo message subscriber service, and this will definitely be a SpringBoot or a Spring component, so I'm going to quickly use this. And now we will inject our our client class to this. So it's going to be private AWS client basic SQS client, and to auto wire this, there we have the entire thing ready. Before we move further, we need to understand what are we trying to achieve here. So we will need to create a polling mechanism which will try to get the messages from SQS on a regular interval, and we would need that mechanism to work in a multi-threaded fashion, more like parallel. So like we have thread 1 trying to get message, and at the same time thread 2 is also trying to get the message from the same SQS. When the call is made to SQS, there is a possibility that you get a valid message back, and there is a possibility that you get an empty message. And the number of threads doing this work will be configurable, so that will be defined in our application YAML. And we want these threads to go to SQS in a fixed schedule or on a regular interval basis. Okay, so let's define a few things first. We're going back to our application YAML, and here we're going to define a property polling threads and give it a value of 2. So these are the 2 parallel threads which will continuously go to SQS and try to get the message back from the queue. Let's define it as part of our class, private np polling threads, and this will be coming from the property. So I'm going to go here, quickly copy this, come back to our class, do this, and change this to the property polling threads. And next I have to create the polling method. Private void start SQS poll, and inside this we will initialize our scheduled thread pool executor service. So I'm going to create an instance of a scheduled thread pool executor. I'm just going to call it executor, and inside this method I'm gonna initialize this with the number of threads, 2 for now. Alright, next we want a place where we're going to use our basic SQS client, and that class we will provide to the executor. So let's get ahead and create that class. I'm going to create that class here. I'm going to call it receive message command, and this class will have a private property of the same thing because we will need this. I'm going to call it basic SQS client, and this will implement runnable. Alright, and we're going to provide it with a constructor. Which will help us initialize this property mostly. So I'm going to quickly do this and then do this. Alright, so when we create the new instance of the receive message command, we will pass this already initialized class to it, and that way when the run method will run, we will have that initialize object, and with which we will get the message. So there's a method called receive message. It takes an argument of the queue, which is this. We already have that as part of the client. And let's see what this message returns. It returns you a receive message result. So receive message result equals result equals this, and there we go. So now we have a very basic implementation of receiving the message from the SQS client using the AWS demo SQS client, and this will happen in a regular fashion. So let's write that logic also. So for int worker equals 0, worker less than polling threads, worker plus plus. Right, so here we're gonna call our executor service using the scheduled at fixed phrase method, and now we're gonna do new receive message command and pass in the basic client. Initial delay is 0, and we want this to happen every second. So this is time unit dot seconds, sorry, milliseconds. Alright, so now we are scheduling 2 services. This loop will run 2 times, and those 2 services will try to get the message from the queue every second. And in order for us to view that, let me put a log here. And that will be log.info message received. Is your result. But we do need to keep in mind that this message can be empty if there are no messages on the queue. So I'm going to put a little check on above here, null not equal to result. And in that case, we'll be able to log the messages only if they are present, or the result only if it's present. Before we move forward, there are a few more things which we need to fix. So one is we should be parameterizing this and defining it as part of our application YAML. So I'm going to go here. I'm going to say polling rate, and I'm going to say 1000. Use this in a class private and polling rate. Use this here, and get this property from the YAML file. And then we need this method to start as soon as the bean is initialized. So I'm going to use the post construct annotation. So as soon as this service is initialized, this method will automatically start. So now it's time for us to start this implementation. So let's do it. So right now we have 25 messages available on the queue, and once we start our service, these messages will be read by the queue, and if our log statement works correctly, they will be logged on the console. Let's start our application now. So I'm going to our main class, right click, run as SpringBoot app, and the application is starting now. And once our bean is initialized, it will call the post construct, and it will start polling. As you can see, we have started receiving messages from the queue. This was the log we put in our receive message command, and we can see the messages getting polled in a regular interval by the 2 threads. And now we have started receiving empty because all the messages have been read from the queue. And at some point of time, the visibility of these messages will expire and they'll go back to the queue, because if you remember, we're not trying to delete the message from the queue, we're just trying to read it, a copy of the message. See, the message were made available to the queue, and we are again able to read them using the same logic. Next is, once we read the message, we have to delete the message from the queue if it's been processed correctly. So let's write that part of the code. So if the result is not null, which in most of the cases it is not, you have to go and look into another property, which is the message on the result. So we're going to go and look at this property, null not equal result dot messages. At the same time, we need to check if, since this is an array list, we have to check if the size is not 0. So we're going to do this. Dot is empty. If it's empty, return false. And if both of these conditions fulfill, we have to delete the message. And to do that, we will use our client dot get client dot delete message. And let's see what this, we're going to use this message. It takes the URL of the queue and the receipt handle. And where are we going to get the receipt handle? Is from the message. So, and since we're getting only one message at a time, it's for now it's safe to assume that we can get the 0th message and get the receipt handle from that. Or receipt handle. So in this way, once we have received the message from the queue, we are going to delete it, so that the queue has room for new messages. So let's test this logic. So it's time for us now to test this logic. So as per the logic, we will receive the message, and if the message is not empty, we will try to delete this message. So I have put a delete message log here, so we will know which receipt handle is getting deleted. So let's start it. And as you remember, we have 25 messages on the queue, so this should work 25 times, and after that we should not be seeing the delete message again. So our application is starting now. Alright. So yeah, message received, deleting message, message received, deleting message, and this should happen only for 25 times, and after that we should see empty messages getting received and no message getting received after that, even if, since there are no more messages left on the queue. Yep. So what I'm going to do next is, if you remember, we had the publisher service. I'm going to start the publisher service as well, because both of them can run parallelly. This is running on 8060, that will run on 8050. So that will try to put messages on the queue, and this guy will try to read the messages on the queue. And let's see if that works. So I'm going to go to publisher and run as SpringBoot app. Okay. So now we have two different consoles to look into. So let's go to the publisher console. Okay, so we have started putting messages onto the queue, and let's go to the subscriber and see. It has started receiving the messages and deleting the messages. So this is how we have established a publisher subscriber model, where publisher is continuously trying to publish messages on the queue, and you have a subscriber who's trying to read those messages and do something. For now, that's just logging, but in your applications, you will do much more than just logging. But this is how we establish this asynchronous processing, where your publisher do not care what's happened to your message once it receives, or once it is sent on the queue. At the same time, your subscriber or your consumer of the message does not care from where the message is coming from. With this, we have come to the end of part 3 of this video series, and in this video demo, we were able to read messages from the queue and established the publisher-subscriber model, where a publisher was writing the messages on the queue and the subscriber of the queue was reading those messages. In the next video, we will try to understand some of the AWS SQS settings. If you remember, during our first video, we created the SQS with the default settings. We're going to talk about some of those settings and see how those settings can be adjusted and how those settings impact our applications. See you in the next video.